Hi guys, Mr. T here, and today we're going to talk about dividing P of X by A minus A. Basically, we're doing synthetic division. This is just going to be a general introduction of the basics of how to set it up and how to do the synthetic division. So that's first part. We're going to do a couple examples, and then we're going to talk about three ways they can ask the question, and so that we might change how a couple of things. But as far as doing all the things that it goes with it and totally factoring things, that's in my other video. This is just an introduction on how to get it set up, how to do the synthetic division, and three different ways that they could ask the same kind of question, but you would work it the same way. So let's get this thing started. First thing here, we did long division, and so here's an example of long division on the left hand side. Okay, now so we see how this guy here. Now, first thing I wanted to show you here is that we were trying to see if x minus 2 was a factor. It is not a factor because it had a remainder of 50. Okay, but that's okay. And you notice, so now we're going to go to synthetic division. So we're going to take this dividend and write it over here and just drop all of the variables. And so just like a matrix, you got to have everything lined up just perfectly. So you notice there's not an x to the first power term, so we put a 0x. Well, we better put the 0 here too. It's very important that everything is lined up with a descending exponent on the variable, okay? And so if there's something missing, you have to put the 0 in or things are going to not work out at all. Okay, so that's not too bad. If you've done some matrices, that's not a big deal. Now, what about this 2? This is x minus 2, but this is positive 2. So when we're looking for, in the fact, could be a factor. So then we're going to do it for the possible 0 here. So that's going to end up being the opposite in this situation. Okay, so that's what's going on there, and we'll do a couple more examples to walk you through there. But what's going to happen here? So I got a box here that's going to show you stuff. So what we're going to always do, and this is a quick overview, and go over the details again. All right. So what happens first here is we're going to bring down the 3. Okay. And then from here we're going to do something called multiply, add, multiply, add, multiply, add. And when we multiply, we will always multiply by the 2. Okay. So we're going to do 2 times 3. There's your 6. Now add, get your 10. So 10 times 2, 20. 0 plus 20 is 20. Okay. Now we're going to multiply times 2 again, and the 40 will go there. Okay. 40. So and then we add 10 plus 40 is 50. Okay. So we brought the 3 down, multiply, add, multiply, add, multiply, add. 50 is called the remainder. So let's do some comparison here. So this row right here is exactly as the dividend, right? This is our remainder down here. So is this. Okay. Now, here's our quotient across the top, correct? And then there's the quotient down here. So that'd be the constant, x to the first, and then x squared. So that's how those things work together. A lot quicker and easier, isn't it? There is one challenge here. It has to be x plus or minus a number. If it's more than that, you have to do long division. So it only works in those scenarios. All right. So that's long division. That's synthetic division. Same thing. Now, how could we express these answers? There's a couple of different ways we could do that. So I want to go back up a little bit to 12 and 13. Let's look at these two examples. So this is 12 divided by 4, okay, equals 3. Okay, so how can I, and it gives me a remainder of 0. So I could express that as 12 is equal to 4 times 3. So the dividend is equal to the divisor times the quotient, okay? Or I could say the dividend over the divisor is equal to the quotient, all right? So that's one way you could do that, whether that's polynomials or not. Those are the different pieces that you would do. Now I'm going to look at one more here with 13 because this one doesn't come out even, okay? But the same process applies. So, okay, 13 divided by 4 is 3 with the remainder of 1, right? So there's two ways you could write that. You could say that the dividend 13, okay, is equal to the divisor times the quotient plus the remainder. So in that scenario, we're just straight up plus 1 to get that job done. And that's true. 3 times 4 would be 12. Plus 1 is 13. Okay. So if you express it that way, that's how you would write it. But let's do it this way. So 13 over 4, so the dividend over the divisor is equal to the quotient plus the remainder over the divisor. Okay? The remainder over divisor. So 3 plus 1/4. Isn't that the same thing as just 3 1/4? And 3 times 4 plus 1, that'd be 13 over 4. So they are equal. Okay? So how do I know which one to put? Instructions, context. Okay? That's not the main thing. Just to kind of show you some different ways to write that. So I'm going to take the previous problem and rewrite those in these two formats real quickly. So here's my answer. So one way I could express this would be to take the dividend, okay, over the divisor. So that'd be 3x cubed plus 4x squared. I don't have, and then when I'm doing this way, I can skip that dude and just write plus 10 over or divided by x minus 2. See, that's what that would be as a factor, is equal to, okay, 3x squared plus 10x plus 20, then plus the what? Plus the remainder, which would be 50 over x minus 2. Okay, so that's one way to do that, and that would be similar to this idea of 13 over 4 equals 3 plus the remainder over the divisor. Okay, so that's that method. Okay, then another way we could write that would be, we said that the dividend, put a green, 3x to the third plus 4x squared plus 10 is equal to, okay, equal to the divisor, x minus 2, times the quotient, okay, which is 3x squared plus 10x plus 20 plus the remainder, and that's just straight 50, not 50 over x over 2 this time. Okay, and that is very similar to this idea here. 4 times 3 plus the remainder. No fancy stuff to it. Okay, and I don't know why I switched the order for whatever reason, but it's the same idea. But that's not the primary thing. It just kind of sets you up. You can go back and forth and double check that. Now I'm going to go over two examples. Okay, I'm going to go over two examples of the process of doing synthetic division. Okay, so here is an example right here. And I guess that original problem would have been what? Just to remind you, 4x to the third plus 3x squared plus 2x plus 1. And that would have been x plus 2 if they were talking about a factor. Okay? So how do we get this thing started? Bring down the first piece, okay? And then we're going to multiply. So that would be negative 2 times 4, negative 8. Add, that gives me negative 5. Multiply again, because we're always doing what? We're always multiplying by this guy over here, right? So be negative 2 times negative 5. It gives me 10. 2 plus 10 is 12. Okay. Now again, it's going to be negative 2 times 12. That is going to be negative 24. 1 plus negative 24 is negative 23. Okay, and so negative 23 is my remainder. So I would say that x plus 2 is not a factor because it doesn't come out even. I'd say that negative 2 is not a 0 because it doesn't come out even. Okay, but how could I write this answer? Well, one of the way we could write that would be that we could say that x plus 2 times 4x. Now, is that going to be 4x to the third? No, we divided it, so it can't be third anymore. It's going to go down. It's going to be a square. Okay, minus 5x plus 12, and then minus 23. So, and then could put that other guy up there. So that's one way we could express that. Well, it's just bring down, multiply, add, multiply, add, multiply, add. Okay, let's look at another example here, and then we'll talk about the different ways it could be asked. So here's our original expression, and we're dividing it by x plus 2. That ordered, that factor there, and so that means we're going to put negative 2 up here. Okay, so we're going to bring down the 2. All right, and then now we're ready to do that multiplication thing, right? And do that multiplication thing. Always multiplying by that number right there up in the corner. So negative 2 times 2. See if I can keep consistent here. That'd be negative 4. Then 1 plus negative 4 would be negative 3. Now we're going to multiply. Negative 2 times negative 3 is 6, positive 6. And negative 19 and 6 will give me negative 13. Okay. All right. Now we got negative 2 times negative 3. That's going to give me positive 26, right? Positive 26. Now we're going to add. So multiply, add, multiply, add, multiply, add. And that's going to give me positive 12. Okay. And then 12 times negative 2 is negative 24. Add those guys, and we come up with a 0. Well, that's kind of cool, right? That's kind of cool. So this expression here, 2x to the fourth plus x to the third minus 19x squared minus 14x plus 24. How could we do that? Well, we're saying that you could take x plus 2 times, remember this is constant, x to the first, x to the second, x to the third, one less than that guy up there. It's not always to the third, just one less than that guy up there. So it's 2x to the third minus 3x squared minus 13x plus 12. So if I multiply these two together, that'll give me that dividend we started with, okay? Because we got, and so this is a factor. It comes out nice and even. So that's the process of, we first compared long division to synthetic division. We looked at two ways you could write the answers. Now we've done two examples. Now I'm going to show you three ways this same question can be asked, okay? But the way you work it doesn't change, okay? Okay, so first of all, let's get my face out of here, all right? So here we go. We got function f of x, which is the one we just got finished doing. And then we do all this work right here, okay? And then what we would say is x plus 2 a factor of the function? And you would say, because we got a 0 remainder, yes, okay? So that's one way we could look at it. And again, I want you to remind you, if it's x plus 2 as a factor, you're going to do the opposite because that's what we're doing. We're the 0, okay? We're checking for 0. Because if you graph that, it will actually cross at negative 2, 0, right? That's how that works. We've done a lot of practice with those polynomials. Okay, so that's one way you could do this exact synthetic division, and that's one way you could be asked a question. Okay, another way they could phrase the same exact thing is, say, here we are, f of x, you got your synthetic division up. They could say, is negative 2 a 0 of the function? Okay, So this is another way they could ask the question. And so in this case, when they have the -2, you're just going to take this guy right here and go straight over here. No changes, right? No changes at all for that, because that is what we're checking. This is the 0, and its partnering factor would be x plus 2. But in this case, we're not been asked anything about the factor. We're just smart and realize that if they're asking for -2 as a 0, the factor would be x plus 2. And what would we say is our answer here? We would say a big time yes, because we have a remainder of 0. It is a 0 because it pushed out a 0, right? Now, our next question they could ask is, remember when you have like let's go here, like f of -2, f of negative, find f of -2. Well, one way we would normally do it's called direct substitution. We would take -2 and plug it in for each one of the x's and simplify it, right? For direct substitution. That's how we would normally do it. And I encourage you to still do it that way. But there is another way you can find the same answer. Okay? It's called synthetic substitution. So did you see any changes though? No changes here. Okay? So the thing you got to be careful of is noticing that when they're asking for f of -2, you're going to not change the sign. Okay? And then you can answer the question at this point. Find f of -2. And you would say, well, f of -2, well, that equals 0, right? Okay, that is 0. All right, let me review one more time, okay? This is the exact same problem with 0 changes, right? 0 changes. So let's back up. So here's our synthetic division on this slide here. So bring down, multiply, add, multiply, add, multiply, add, multiply, add. Okay, and you got your remainder 0. It doesn't always turn out to be. The first one had a remainder of 50, right? All right. So the 3 ways you could be asked that question is x plus 2 a factor? You work it the exact same way. Just make sure that you put the opposite sign because you're checking for the 0, right? If x plus 2 is the factor, -2 is the 0. Okay, and then that's one way. The next way is they could ask, is -2 a 0? Do exactly the same thing, and if it comes out to be 0, your answer is yes. If that is not 0, then it's no. Okay? Then another way, and this is a little different, okay, is instead they could say find f of -2 or any other number. And in this case, you just plug that number right over here with no changing of the signs, just like the 0, because that's what you're checking for. And whatever comes out here, you don't care about the rest of it. You only care about the remainder. Okay? And so whatever comes out here will give you the ordered pair that you were looking for. All right. Well, hope that just a quick introduction to synthetic division is helpful to you. Check out the next video about synthetic division, working it out by hand, and it shows you the power of being able to take really big things and break it all the way down to real simple. Okay. Have a good evening. Hope that helps.